Alright, in this video we'll be finding probability with the fundamental counting principle, permutations, and combinations. So let's go ahead and get started on number 1. We have Steve, Mark, Joe, Don, and Ray. So notice there's 5 people there that have been invited to a party. They arrive randomly, and each person arrives at a different time. So nobody's showing up at the same time. And how many ways can they arrive? And so these are 5 different people, and order matters here. Like we care about who's first, who's last. Order matters here. All right, so and how many ways can they arrive? Well, this is 5 items, or in this case 5 people, and we're basically looking at the number of permutations of 5 people. Well, that's 5 factorial, which we could write out as 5 times 4 times 3 times 2 times 1, and you do get 120 ways. So we can use our n factorial formula for this, but the other way to think of this is you're making 5 choices. For the first person, there's 5 people that could arrive first. And once that person's arrived, now there's 4 to choose from for the next position, and so on. So you can think of this problem in terms of permutations, or you can use the fundamental counting principle. In fact, with all permutations, that's true. And how many ways can Joe arrive first and Steve arrive last? Let's see. So we have 5 people. Now, the first person has to be Joe, so there's only one choice for the first position. And the same thing's true for Steve in the last position. So in the second position, there are now, since those 2 are determined, we have 3 people left to choose from, then 2, then 1. And so we're just going to get 6 ways here. So here we're just using the fundamental counting principle. All right. Find the probability that Joe arrives first and Steve arrives last. So this is the probability. Joe arrives first and Steve arrives last. Well, we want to think of this in terms of favorable divided by total outcomes. The number of favorable outcomes would be the number of ways that Joe can be first and Steve last. Well, there's 6 ways for that to occur out of a total of a possible 120 ways. And if you reduce that, you do get 1/20th. So there's a 1 in 20 chance that that's going to occur. That Joe's going to be first and Steve will be last. All right, let's move on to number 2. So you may want to try it if you think you got that basic idea, because this problem's the same, except for in each of these we're finding the probability. In problem 1, we kind of built up to that. In each of these probabilities, you're basically doing all of the 3 steps that we did up above. All right, let's see how you did. Or if you didn't do it, you can just watch me. So you have 7 acts, and they're going to perform one evening at a fundraiser. The order of performance is determined by random selection. Find the probability that Act A will perform third. So notice there's 7 acts. So 1, 2, 3, 4, 5, 6, 7. So we're making 7 choices. We're going to use the fundamental counting principle. Now, A is going to perform third. That means there's only one way to choose that position. And so now that one person is determined, we have 6 to choose from for this first, for being the first act. And then there'll be 5 after that person's picked. And then it'll just go on down, 4, 3, 2, 1. So you can see this is actually 6 factorial. Let's see. which is 720. All right. Now remember, it's the probability that A is third. So it'll be the number of favorable divided by total outcomes. So these are our favorable outcomes. That's where Act A does perform third. There's 720 of those. Out of how many total possible outcomes? Well, we have 7 items or 7 people, and we need to see how many permutations are there. Again, order matters here, so that's just going to be 7 factorial or n factorial. And 7 factorial is 5,040. And so that's our numerator. And you should be able to just throw that in your calculator and reduce it, and you get 1/7. In fact, let me grab mine real quick. You know, when we're doing probabilities, we don't want to be missing problems because of we messed up on reducing a fraction. Let's just, we'll do that. So we would do 720 and then hit the fraction button, 5040, and you can see that that is 1/7. So make sure, use your calculator to help you with these. I mean, if the fractions are smaller, the numbers are smaller, you probably could do it by hand. But otherwise, take advantage of the technology here. Okay, so on the second one, Act E will be 6th and B will be last. So let's go ahead and set up our 7 choices that have to be made, basically for the order of the acts. 1, 2, 3, 4, 5, 6, 7. So we do have 7 there. So Act E will be 6th, that's going to be here, and B is going to be last. So there's only one way to choose those 2 positions. E is going to be 6th and B will be last. That means there's 5 people left, so who's going to be first? We have 5 people to choose from, and then only 4 now that we've got this position chosen, then 4, then 3, then 2, then 1. So you could actually see this is 5 factorial, which is 120. And remember, we said there were 7 factorial was the total number of possible permutations of these 7 acts. And we said that was 5,040. So the probability that E is 6 and B is last is going to be the number of favorable outcomes. That's where E is 6th and B is last. That's 120. Out of a total of number of 5,040 possibilities. And if you reduce that, you should get 1/42. Now hopefully you're getting more comfortable. You might try C and D if you didn't try them before, and then watch the video. All right, let's see how you did. So what's the probability of getting C, then D, then B, then A, then G, F, and E? Well, in how many ways can this order occur? Well, this is one of our 5,040 permutations. So there's only one way to get this order of performers, of the performers out of 5,040. So that's it. And on the last one, we want to find the probability that D or F is last. Well, let's go ahead and make our 7 choices. So we just need D or F to be last. That means there's 2 choices for the last position. Now, one of them will be in that position. So for the first position, there's now only 6 to choose from. For the second position, 5, and then you just work your way on down. So basically, this is 6 factorial times 2. And if you multiply that out, you're going to get 1,440 out of a total of 5,040 possible permutations or orders of these acts. And if you put that into your calculator, you do get 2/7. All right, let's move on to number 3. So a political discussion group consists of 5 Democrats and 11 Republicans. So notice that's a total of 11 people. 4 people are selected to attend a conference. So you can see here that, like in the last 2 problems we did, order mattered. In this case, you can see that order doesn't matter. You're just picking 4 people to attend a conference. It has nothing to do with order. We're just picking 4 people. So in how many ways can 4 people be selected from this group of 11? Well, if that's 11, choose 4, and you get 330. In how many ways can 4 Republicans be selected from the 6 Republicans? Well, there's 6 Republicans to choose from, and we're choosing 4, so that's 6 choose 4, and we get 15. So we want to find the probability of getting 4 Republicans. Basically, all 4 of our selections are Republicans. So that's going to be the number of favorable outcomes divided by total. So favorable outcome is choosing 4 Republicans. There's 330 ways to do that. Oh wait, I did that backwards. How many ways can we choose the 4 Republicans? Well, we chose 4 from 6. There was 15 ways to choose 4 Republicans out of a total of 330 possible ways or combinations to choose 4 people from the group of 11. If you reduce that, you get 1/22. All right, let's move on to the next page. So Powerball is a lottery game in Texas and several other states. In order to win, you must choose 5 different numbers from 1 to 69 and a Powerball number from 1 to 26. I think the 5 balls are white and then the Powerballs are red. You win the grand prize if you choose the correct 5 numbers. Notice order doesn't matter here. You just have to pick the right 5 numbers and also the correct Powerball number. If you buy 1 Powerball ticket, what is the probability that you will win the grand prize? Well, the probability of winning grand prize, of course, is the number of favorable outcomes divided by total outcomes. Well, let's do the total outcomes first. In how many ways can you choose 5 of these white balls from these balls from 1 to 69? Well, that's 69, choose 5. And if you do that, you find that it is 11,238,513. But remember, you're also choosing a ball that's a Powerball. You have 26 choices here. And so this is the number of ways to choose the 5 balls. There's 26 ways to choose the Powerball. And so there's a total of, if you multiply that out, 292,201,338 ways to choose both. So a favorable outcome is getting the one and only correct 5 numbers for the first numbers and the correct Powerball. There's just one way to do that. And then there's a total of 292,201,338 ways to choose these 5 balls and then the Powerball. And so you have a 1 in almost 300 million chance of winning. Not the best of odds. Don't plan your retirement around that. Let's move on to number 5. A parent-teacher committee consisting of 4 people is to be selected from 15 parents and 5 teachers. So notice there's a total of 15 plus 5, 20 people. Find the probability of selecting 2 parents and 2 teachers. All right, so we want the probability of getting 2 parents and 2 teachers. So again, it's the number of favorable outcomes divided by total outcomes. Well, favorable outcomes is getting 2 parents and 2 teachers. Again, I think I'll start with total outcomes. Basically, you're picking 4 people. So there's a total of 20 people to choose from, and you're choosing 4. So this is 20 choose 4. And if you do that, you'll find that it's 4,845 ways to choose 4 people from this group of 20. So that's our denominator. Well, in how many ways can we choose the 2 parents and the 2 teachers? So these are our favorable outcomes. Well, there's 15 parents to choose from. And we want to choose a favorable outcome is that we're getting two parents. So in how many ways this is 15 choose 2, the number of ways we can choose 2 parents from the 15. Again, order doesn't matter here. We're just picking people to be on a committee. So 15 choose 2 is 105. Now, that's just the number of ways to choose the 2 parents. To choose the 2 teachers, notice there's 5 to choose from, so that's 5 choose 2. And if you figure that out on your calculator, I didn't do any of these, but I guess I could do one of these real quick. So it's 5, and then you go into the probability menu. And we want to choose option 2 and then put in the 2. And so you do get 10 here. So basically, if there's 105 ways that you can choose the 2 parents and 10 ways that you can choose the 2 teachers, then there's 105 times 10 ways to do both. And so that's 1050. And if you reduce that, you will get 70 over 323. Now, I just want to warn you that there is the possibility that your fraction will have such big numbers in it that the calculator is not able to handle the reduction or reducing it. And so when that happens, the only thing you can really do is divide the 2 numbers. Just do 1050 divide 4,845, and you would write your answer as a decimal. In this last problem, that's what we're going to end up doing. So I would encourage you to try this one. It's using the same ideas as what we've been doing with combinations, and then watch the video. All right, so if you are dealt 4 cards from a shuffled deck of 52 cards, find the probability that all 4 are hearts. Write your answer as a decimal rounded to 6 decimal places. Okay. So the probability of getting 4 hearts is the number of favorable outcomes divided by total outcomes. Of course, favorable outcomes is the number of ways you can get 4 hearts. And total outcomes is just the number of ways you can choose 4 cards from 52 unique different cards. So I'm going to go ahead and find the number of total outcomes. It really doesn't matter which one you do first. You have 52 cards and you're choosing 4. And so there are a total of 270,725 possible basically hands of cards that you could get. That's our denominator. And then the number of favorable outcomes, well, that would be choosing 4 cards that are hearts. So let's just say favorable outcomes, where you get 4 hearts. Well, that means we're getting all hearts. Well, how many hearts are there in the deck? Well, there's 13 of each suit. There's 13 hearts, and we're looking to choose 4. How many ways can we choose 4 of those hearts? And you get 715. So that's our numerator. Now I'm going to see if our calculator will actually do this one or not. 715 over 270,725. Notice it did not reduce the fraction. The numbers are just too big. We know the numerator and denominator are divisible by 5, so you could certainly divide them both by 5, and then it might be able to reduce the next fraction that you get when you divide the numerator and denominator by 5. But here we're asked to give a decimal answer to 6 decimal places, so we'll stop right here. And since that's a 1, the 4 will remain a 4. Or wait, no, actually we'll stop at the 1, and because of the 0, it'll stay a 1. And so we're going to get 0.002641. So your chances are not great. 0%, basically 0.3% about, pretty small chance that you would get 4 hearts if you drew 4 cards. All right, that's it for this video.